Hello, everyone. I'm Mingling from Southeast University, China. In this video, I'm going to introduce our work in the paper, A Quantitative Analysis and Optimization on the Cache Behavior Influenced by Literary Pools. As we all know, limited by the fixed length of RISC instructions, it is impossible to represent an arbitrary imitative value in a single instruction. Instead, these values are normally stored in the text segment and referenced by corresponding loader instructions. This memory block used to store these immediate values is often called a literal pool. However, as the example shown in this slide, when the instruction cache at address of 8280 is executed for the first time, it triggers an instruction cache miss. The whole main memory block in the orange box is filled into the instruction cache. In this case, the literals from A2AC to A2B4 are inevitably cached into the instruction cache without any further reference. Similarly, instructions adjacent to the literal pools could also be filled into a data cache line during a data cache line filling. Obviously, literals in the instruction cache and instructions in the data cache are useless and will never be accessed. This useless but cached data wastes the precious memory bandwidth and power, while occupies the cache capacitance that otherwise could be used by useful data. The left figure in this slide shows the distributions of literary pools among different benchmarks. As we can find, most literal pools are smaller than a cache line size, which makes the code segment fragmented. To mitigate the aforementioned influence caused by literal pools in this paper, we propose to reallocate literal pool or RLP algorithm, which merge small literal pools into bigger ones without any hardware overhead. We evaluate the effectiveness of RLP with 6 2006 benchmarks. Experiments results under the configuration of 16 kilobyte two-way associative cache for 1 billion instructions show that RLP reduces cache misses up to 24% in iCache and 38% in Dcache compared to those of original literal pool layout, which demonstrates the effectiveness of the proposed method. Interested readers can also download our open source code at the bottom link. Thank you for your attention.